Iceberg aircraft carrier, Britain's WWII Pyke experiment. Project Habakuk originated during World War II, emerging from the need to counteract the German U-boat threat in the North Atlantic. Conceived by the British, the project aimed to create an innovative solution to protect vital maritime supply routes. The strategic need for an aircraft carrier in the North Atlantic was urgent. Traditional carriers were vulnerable and scarce, making it essential to develop a new type of vessel capable of withstanding harsh conditions and providing continuous air support over vast oceanic expanses. The concept of using picrete, a mixture of ice and wood pulp, revolutionized military engineering. This unorthodox material promised to be both strong and buoyant, offering a potential breakthrough in the construction of large, durable floating platforms for aircraft operations. Picrete's properties included remarkable strength and slow melting rates. These benefits made it an attractive option for constructing a massive, resilient aircraft carrier. Its ability to remain solid in cold waters presented a unique advantage over traditional construction materials like steel. Initial proposals and design sketches for the vessel envisioned a colossal structure capable of supporting multiple aircraft. Engineers drafted plans for a floating airbase that could endure torpedoes and artillery fire, fundamentally altering naval warfare strategies in the Atlantic theater. Key figures and scientists involved in Project Habakuk were instrumental in pushing the boundaries of traditional naval engineering. Their collaborative efforts and innovative thinking laid the groundwork for exploring unconventional materials and designs, bringing a unique vision to life during a time of global conflict. Geoffrey Pyke, a British inventor, played a pivotal role in suggesting the use of picrete for constructing a massive floating airbase. His unconventional proposal caught the attention of military leaders and scientists who were eager to find innovative solutions to strategic challenges in the North Atlantic. Experimental trials and tests of picrete were conducted to assess its feasibility as a construction material. These trials demonstrated picrete's impressive strength and durability, even in harsh conditions. The tests provided valuable data that fueled the project's momentum and optimism among its proponents. A prototype of the vessel was constructed in Canada to further evaluate the practicality of building with picrete. This crucial step allowed the team to address real-world challenges and refine their approach, bringing them closer to realizing their ambitious vision. The construction of the prototype faced numerous challenges, including logistical issues, environmental factors, and technical difficulties. Despite these obstacles, the team persevered, driven by a shared belief in the potential of their groundbreaking project to revolutionize naval warfare. The envisioned size and specifications of the final aircraft carrier were enormous. It was to be 2,000 feet long, 300 feet wide, and 200 feet high. This would allow it to carry hundreds of aircraft and support extensive military operations. Potential advantages of a picrete carrier over traditional steel ships included its resilience and buoyancy. Picrete's composition, a mixture of ice and wood pulp, made it more durable against torpedoes and gunfire. It also required fewer strategic materials like steel. The proposed armament and aircraft capacity of the picrete carrier were impressive. It was to be equipped with anti-aircraft guns and capable of housing up to 150 aircraft. This would provide significant air support in the North Atlantic, enhancing Allied defenses. The anticipated lifespan and maintenance requirements of a picrete vessel were surprisingly viable. With proper care and refrigeration, the ship could last several years. Regular maintenance would involve replenishing its ice, ensuring the structure remained solid and combat-ready. The timeline of Project Habakuk from inception to abandonment was brief but intense. Conceptualized in 1942, it saw rapid development and testing phases. However, by 1944, logistical, practical, and financial issues led to its discontinuation, leaving it as an intriguing wartime experiment. Securing funding and resources for Project Habakuk required significant effort, given its unconventional nature and the wartime context. The project drew interest from high-level officials who saw its potential strategic value. Allocating resources amidst ongoing conflicts posed a considerable challenge. The collaboration between British and American forces was essential for Project Habakuk's progress. Both nations pooled scientific expertise and resources to explore the feasibility of a picr aircraft carrier. This partnership highlighted the shared strategic interests and technological ambitions during World War II. Technical obstacles and engineering hurdles were abundant throughout Project Habakuk. Researchers had to devise methods to work with picr, a material with unique properties. Overcoming these challenges was crucial for advancing the project's development and ensuring the proposed vessel's viability. Environmental conditions significantly impacted picr's durability. Temperature fluctuations and exposure to saltwater presented ongoing concerns for maintaining the material's integrity. Understanding and mitigating these environmental effects were critical for ensuring the project's long-term success and operational effectiveness. Project Habakuk had a notable impact on wartime naval strategy. The concept of a massive ice-based aircraft carrier introduced innovative thinking into military planning. Although ultimately abandoned, the project's ambitious vision influenced subsequent naval engineering and strategic considerations during and after the war. Project Habakuk was eventually abandoned due to a combination of technical challenges, high costs, and changing wartime needs. The concept of a picr aircraft carrier, while innovative, proved impractical under the pressures and timelines of World War II. Post-war analysis revealed significant insights into materials science and engineering. While the project didn't reach fruition, it highlighted the importance of adaptability and creative problem-solving in military contexts. Engineers learned valuable lessons about the limitations and potential of unconventional materials. Project Habakuk's legacy endures in military innovation, demonstrating the value of thinking beyond traditional boundaries. Even though the project was not completed, it inspired future generations of engineers and scientists to explore novel solutions to complex problems. Picr was one of many experimental materials explored throughout history. Its unique properties, such as strength and reduced melting rates, offered intriguing possibilities. However, like many innovative ideas, it faced practical challenges that ultimately limited widespread adoption. Unconventional thinking in wartime engineering has often led to breakthroughs. Project Habakuk exemplifies how necessity drives innovation, pushing the boundaries of what is considered possible. Such projects remind us of the creative potential unleashed during times of great need. The announcement and details of Project Habakuk intrigued the public and media during World War II. Stories about a potential ice-based aircraft carrier generated curiosity and skepticism. The audacious concept of using picr captivated imaginations, showcasing the era's innovative spirit. From the bold ambitions to the practical challenges, Project Habakuk taught valuable lessons. It highlighted the importance of rigorous testing and adaptability in engineering endeavors. The project's blend of creativity and practicality continues to inspire modern engineers and military planners alike. Imagining a successful Project Habakuk opens fascinating scenarios. A fleet of picr carriers could have altered naval warfare, providing strategic advantages in the North Atlantic. This hypothetical success underscores the potential impact of unconventional solutions in critical wartime situations. Interest in picr did not vanish with the war's end. Modern engineers and historians revisit the material's potential, exploring its feasibility with advanced technologies. The enduring curiosity indicates the timeless appeal of pushing boundaries in material science and engineering. Project Habakuk remains a symbol of wartime innovation and bold thinking. Its legacy persists in inspiring unconventional approaches to problem-solving. In the broader context of World War II, it exemplifies the era's relentless pursuit of technological advancement and strategic ingenuity.